Hello and welcome to this webinar hosted by Element 14. Today's topic is getting started with Raspberry Pi and accessories. We're very fortunate to have with Gough Lui, who will be presenting this interesting topic for you. If you have any questions for him during the course of the webinar, please put them either into the chat or the Q&A window, and I'll ask them of him at the end. Without further ado, I hand you over to Gough. Take it away.
Thank you very much, Christian, and thanks for taking the time out of your day to learn a little bit more about getting started with the Raspberry Pi and accessories. As an avid electronics and embedded systems enthusiast, when the Raspberry Pi was first announced, I was one of those who eagerly pre-ordered one and counted every last day until it arrived. It was one of the more exciting things to happen to me since the Arduino, because I realized its potential when it came to the computing power. In fact, it proved to be the impetus that caused me to start my own LAMP server and eventually blog about all facets of technology. It's also part of the reason why I'm here today. Today, the Raspberry Pi and its community continues to be strong, recently having celebrated over 2 million Raspberry Pis sold as of October 2013. In today's webinar, we will be looking at what is a Raspberry Pi, we'll be looking at the Raspberry Pi hardware, essential accessories you'll need to get started with the Raspberry Pi, as well as other accessories which you can use to extend the capabilities of your Raspberry Pi. We'll also look at gathering project ideas and getting started, as well as finding help and support when you need it. And we'll look at the differences and limitations of the Raspberry Pi platform as a whole. So let's start with what is a Raspberry Pi. The Raspberry Pi is a $25 or $35 US single board computer built around the Broadcom BCM2835 V6 system on a chip. The project takes its inspiration from the former BBC Micro, which was an affordable home computer designed for education and taught many computer users today the fundamentals of programming and inspired them to be interested in the field of computing. The Raspberry Pi seeks to emulate this same success for a whole new generation, being aimed at education as a low-cost computer for people to learn programming on. It has found favor with many hobbyists because of its unique attributes, such as its low power consumption, small form factor, low cost, and relatively capable hardware for the price and for its size. The hardware itself is comparable to a bottom-end smartphone today, or a desktop computer of roughly 15 years ago, so it's not a replacement for your desktop computer. That wasn't its aim. Instead, it focuses on being a low-cost educational computer and also the embedded market segment where even lower powered microcontrollers are the norm. So embedded systems are the systems which are integrated into your appliances where the philosophy is completely different. Instead of focusing on general purpose multitasking, embedded systems focus on doing one or just a handful of tasks and live within constraints such as power, computing power, memory, and storage. So as well as being efficient with your code, it's important to utilize the hardware efficiently. So in embedded terms, the Raspberry Pi packs a lot of punch. It's powerful to drive even a full high-definition display, run a graphical desktop, web browser, media center, or even a web server. You can't say the same about most microcontroller platforms of today. It's not just a repackaged bottom-end smartphone or an old computer, however, and the reason should become apparent to you by the time we finish this webinar. So let's take a look at the Raspberry Pi hardware. The Raspberry Pi comes in two variants. There is a Model A and a Model B, and the other thing to note is that early Raspberry Pis were a little bit different. So the initial revisions had slightly different GPIO pin allocations. They didn't have a P5 or P6 header, and they had only 256 megs of RAM. But if you're only just starting your Raspberry Pi journey today, there's no need to worry because the Pis you can buy today are the latest and greatest. So let's take a look at what you get when you order a Raspberry Pi. So what you'll get is something that looks like this. It's a cardboard box. It's inside, you'll see a static shielding bag, and inside that is the Raspberry Pi itself. So here I've got in this hand, this is a Model A board, and this is a Model B board. So they differ subtly, and I will explain why in a moment. So the Model A board and the Model B board differ in cost. So the Model A is the $25 unit, whereas the Model B is the $35 unit. But the Model A board doesn't have Ethernet, so you'll notice that one of the Ethernet ports is missing. It also only has one USB 2 port as opposed to the two USB 2 ports on the Model B. So the Model B proves to be the more popular board because it's more flexible. And the other thing is that the Model B now ships with 512 megabytes of RAM, whereas the Model A only ships with 256. So let's take a quick tour of the Model B board now. So this is the Model B board right here. If we take a look at the left side, what we can see is on the bottom corner, the micro USB connector, which is used to supply power to the board. And on the underside, just here, there is a SD card slot, which is used to plug the SD card, which holds the kernel and the operating system for the board. Now, along the top edge, there are connectors, your RCA for your composite standard definition video out, as well as a 3.5mm stereo audio out jack. Across the right side, we have the two USB 2 connectors for the Model B. On the Model A, you will only have one, and the Ethernet jack on the bottom. And on the bottom side of the board, there is the HDMI port. So that's the ports on the side of the Raspberry Pi. But on the Pi itself, there are a couple of useful things to note. And the first one is this top row of pins, which is P1. This is the GPIO port, the 26-pin GPIO port, which most peripheral expansion boards will use. And just below that on revision 2 Raspberry Pis is the P5 header, which is used for audio GPIO. So the Wolfson audio card definitely needs that. We've got the P2 and P3 pads, which are in between the composite video and the 3.5mm stereo jack, and these are the JTAG ports for the video core, the GPU on the Raspberry Pi, as well as the Ethernet controller. So normally these don't need to be used, they're just more for diagnostic purposes. There's also the P6 header, which is just here on near the bottom edge. This is used for resetting the Raspberry Pi. So aside from that, there are also two flexible flat cable connectors. This one, which is close to the SD card, is S2, it's the display serial interface, and this is normally used for LCD screens, although I'm not aware of any products on the market which use this at the moment. And the one near the Ethernet port, which is S5, and this is the camera serial interface, and this is used for the camera. And on the top corner, there are useful LEDs which indicate SD card activity, power to the Raspberry Pi board, and the Ethernet status, full duplex, link, and 100 megabits connection. So that is the Raspberry Pi board itself. It's not the only thing you need to get started with the Raspberry Pi, however. This is merely the foundation. You will need some essential accessories. So let's take a look at those. The first thing you'll need is a power supply, so something that looks roughly like this. So you might know this as a mobile phone wall charger. It's quite similar to one of those with a USB port at the bottom. So this will serve as the power supply for the Raspberry Pi. Since the Raspberry Pi isn't a regular USB peripheral, it shouldn't be powered from a computer's USB port. The Model A requires about 500 milliamps of current, and the Model B requires about 700 milliamps, all at 5 volts. But when you start throwing in things like peripherals or overclocking, then the current consumption increases, and you can be looking at anywhere from 700 to 1,500 milliamps of current required. And that's much more than a regular USB port can provide. So as a result, it's paramount that you use a high-quality USB power supply, which supplies clean power at the right voltage with sufficient current. Examples of this include genuine chargers for USB phones, tablets, anywhere rated between, say, 1,200 milliamps to 2,100 milliamps. But be aware that there are on the market many good-looking counterfeit chargers which don't produce clean power and can cause you problems. So Element 14 does stock a variety of suitable USB power supplies which you can use with your Raspberry Pi. Another thing you will need is a high quality USB-A to USB micro B cable similar to this. So what you'd like is something with a moderate length, preferably made of good high quality thick cable to reduce the voltage drop, with good sturdy connectors. So this will basically plug into your charger, so you'll find the USB port at the bottom and you will plug that in, and the other end goes to your Raspberry Pi to supply it power. So these two items together seem to cause the majority of problems for new users of the Raspberry Pi. If you don't have the right power, say it's unclean or there's insufficient current, you may experience random reboots. You may see crashing, freezing, loss of picture or Ethernet connection, or even SD card corruption. So do be aware of that. There are some simple diagnostic checks you can perform just to check that you're getting the right amount of power, and that's measuring the voltage between test point 1 and test point 2 on the board, and it should show somewhere between 4.75 volts to 5 volts to ensure stability. So tied in with the previous point is the issue of USB peripherals. So while I did mention earlier that there are USB ports on the Raspberry Pi, these aren't regular USB ports in the sense that you might already know them. So the reason for this is that the power for the Raspberry Pi comes in from the micro USB connector and has to travel through the Raspberry Pi out to its downstream peripherals. When you add up the voltage loss through all of this, the capability of the Raspberry Pi to supply current to its downstream peripherals is relatively limited. So these USB ports on the Raspberry Pi are really only good for low-powered USB peripherals, things like keyboards, mice, thumb drive, or maybe even a wireless adapter. But whatever you do, don't plug in things like bus-powered USB hard drives because they require much too much power and the Raspberry Pi cannot supply that. Also, the other thing is you shouldn't be plugging in or unplugging USB peripherals from your Raspberry Pi while it's running because the inrush current from actually plugging in a new device may cause enough voltage drop to cause your Raspberry Pi to reboot unsafely. And that can also cause corruption of the operating system on the SD card. So the other thing you might be thinking is there are only 2 USB ports, which may not be enough for you. So in order to kill all these birds with one stone, you can go with a powered USB hub. So this is a stealth-powered USB hub, one that actually plugs into the wall and has its own power adapter, because that will supply the current for the downstream peripherals from the power adapter rather than placing the strain on your Raspberry Pi. So do make sure you get a high-quality powered USB hub. There are some USB hubs which may backfeed power up the USB host connector back to the Raspberry Pi, and that can cause you some problems like SD card corruption as well. So the next item on the list is an SD card. You'll definitely need one of these. It's mandatory. Without one, you're pretty much not doing much with your Raspberry Pi, and this, as I said earlier, goes into the SD card socket at the bottom of your Raspberry Pi. So this holds the kernel image as well as the operating system or the distribution of Linux which you'll be running on your Raspberry Pi. The minimum size you should get is a 4 GB card because Raspbian is now larger than 2 gigs. However, an 8 GB card or larger is recommended if you want to use the new out-of-box software, also affectionately known as Noobs. So the other thing to be aware of is the performance of your SD card, which actually does have quite a bearing on how responsive the Raspberry Pi feels when you're using it. So I would recommend you choose faster cards where possible, cards which are rated Class 10 or even UHS 1, but do keep in mind that even between different brands of Class 10 cards, their performance does vary somewhat. And the other thing is to choose a high quality branded genuine card to avoid problems like SD card corruption. It's also a great idea to make sure you have a compatible SDHC card reader for your desktop or laptop, if that is the case. The reason is, if you would like to change the software distribution you run on your Raspberry Pi, then you will need to re-image, as in write a new software image to your SD card, and you will need to do that via a computer. So a compatible reader will also allow you to back up what's on the SD card, so you can back up similar to how you would back up your computer or computer's hard disk, so that's also a good idea. If you're using the Raspberry Pi interactively, which I think if you're just starting off with the Raspberry Pi is the best way to do it, you will need to hook this up to a screen somehow. So as I mentioned earlier, there is an HDMI port. If you've got a recent TV with an HDMI port, that is quite simple. You can obtain an HDMI lead similar to this one, and that just plugs into the port at the bottom, and you just plug the other end into your TV, and that's one way to get a signal. But if you don't have a screen which is HDMI compatible, there are other options. So if you've got a monitor, for example, that has a DVI port, then you can purchase a HDMI to DVI cable, which will allow you to connect that. If you've got an even older monitor which only supports the VGA out, you can use accessories such as the PiView, and this is just an HDMI to VGA converter lead. But do be aware, if you're using converters like this, it's best to opt for a converter which is self-powered. Some of the converters on the market may draw too much current through the HDMI port, and that could cause a diode on the Raspberry Pi to be blown. So if you can find something that is powered on its own with its own power adapter, that would be best. If you want to connect to an even older TV, say one of those CRT TVs, there is a standard definition connection available through the composite video out, so you will need an RCA to RCA lead for that. So there are your options in terms of connecting a display. Using it interactively, the other thing you will need is a keyboard and mouse. So there are many keyboards and mice out there. In general, anything that is USB should work just fine with the Raspberry Pi. So moving on, if you've got a Raspberry Pi Model B, another thing you will need to consider is an Ethernet lead. So just your regular Category 5E or whatnot Ethernet lead should be enough, and maybe an Ethernet port on your favorite router or somewhere in the house. So an Ethernet lead will let you hook your Raspberry Pi up to the internet, and that will allow you to do your projects involving the internet or networking, to update the software on it, say software packages under Raspbian, and to download code or run projects that do require the internet. So that is a definite thing that you probably do want to get as well. And finally, one that is often overlooked, which is a case. If you look at the Raspberry Pi PCB on its own, it's pretty vulnerable. You can damage it quite easily if you just accidentally knock it hard, you drop it, or maybe there's some electrostatic discharge. From my experience, a case is a great idea to physically protect the Raspberry Pi from that sort of damage. And so there are a variety of cases available. Depending on your taste, you can have anything from a clear case to one that's raspberry colored to a black case, or even a white case, for example. This is the range of multi-comp cases from Element 14, but there are also other cases if you've got special projects in mind. So such as this one here, this one is a special carbon fiber colored case. It's got special cutouts for the Raspberry, for the PiFace control and display board. So if you are using one of those boards as interfaces, there's a case which will allow you to house everything in the one unit, as well as another case. This one's a blue colored case, but for the PiFace digital instead. So it's got cutouts for the wires to come in and out of your PiFace digital board, and these are from Camden Boss. So there are different products available for your needs, and that means that your Raspberry Pi doesn't have to go unprotected. So from my experiences with the Raspberry Pi, both good and bad, I'd say these are the minimal set of accessories you would need to get started with the Raspberry Pi. But that's not all. You can expand the possibilities available to you if you start looking at some of the other peripherals which are available for the Raspberry Pi. Some of these peripherals can be the regular USB peripherals that you already use from day to day, as long as they are supported by the Raspbian kernel. Otherwise, you may want to interface to other things like your electronics projects, and that's where these expansions come in. So the first one we'll be looking at is the HighBase Digital. So that's this board here. It's an interface which provides you digital inputs and outputs. So on this board there are 8 open collector outputs and 8 digital inputs. The first 2 open collector outputs are shared with the changeover relays which are on the board, and the first 4 inputs are shared with the 4 push buttons on the board. So as you can see, there are terminal strips to connect your electronics to, and there are even LEDs to display the status of each of the outputs so that you can get a grasp of what's really going on. So this simple board just attaches via the P1 26-pin GPIO connector on the back. So if you have a Raspberry Pi, it's as simple as aligning the 2 boards together and pushing down, and there you go. You've suddenly just added the capability for your Raspberry Pi to talk to the real world and interface with your devices, whether that be, say, turning on and off a small LED lamp on your desk, or building anything that you can imagine. This is one of the first steps you might need to take. So that's just one of the options. I'd say it's a good idea to investigate these sorts of add-ons because the GPIO pins on the Raspberry Pi are relatively limited and they are quite fragile. So this board adds valuable protection in the case that you do make a mistake. You don't fry your Raspberry Pi so easily. This is just one of the options. There are other sorts of I/O expansion boards available, and the next one we will look at is the HighBase control and display, which is this one here. So this one features a 16-character by 2-line HD 44870 style display. It also features 5 push buttons on the front, as well as an infrared receiver for interfacing with remote controls, similar to the ones you use for your home appliances and for your TV. And on the top there is a 3-way rocker switch which can go down, left and right. So this is a useful add-on board which also attaches via the 26-pin connector, and it's useful if you want to, say, interface with human beings and you want to show them some status without going so far as to have a full-fledged monitor. Likewise, it's also quite useful for building things maybe like an internet radio where you need to show some status like what song is playing, or if you just want to show what's in your email inbox. This is one way you can do it. So these 2 boards, this one comes with Python libraries, so the HighBase control and display comes with Python libraries, which you can use to integrate it into your software. And the HighBase Digital comes with Python and C libraries and is also supported by Wiring Pi, which allows you to integrate it with other GPIOs as well. For the more advanced user, there is an option as well, the Girduana, and this is a more sophisticated, more complicated way of doing I/O, and it's similar to melding together an Arduino with a Raspberry Pi. So it has an Atmega 328P on board, which and also a pinout which is compatible with Arduino Shields, and this allows you to program from the Raspberry Pi the Atmega 328, so it can run its program independently of the Raspberry Pi. It also features an onboard real-time clock, and that can be important in some cases where you are building projects which need to be aware of the time and date, but don't have a connection to the internet for NTP or a GPS, for example. So there is quite a lot of configurability on this board when it comes to its serial interfaces, but it takes a little bit of getting used to in order to work with. So that is another option, especially for those who are more familiar with the Arduino or who want to use Arduino Shields. And it also has analog input, which, if you're a fan of analog, I'm sure you will appreciate. So let's just take a look at some of the other accessories. So you may have already noticed the Raspberry Pi has an audio output on it. It also has audio output via HDMI, but it has no audio input. So Wolfson have made this, which is the Wolfson High audio card. And this is a newly released accessory using Wolfson's expertise in digital to analog conversion and vice versa, to bring you high quality audio both in and out. So it offers high quality line in and line out stereo, as well as SP-Diff, line in and line out, amplified headphone out, a microphone input, as well as a pair of inbuilt microphones, digital microphones, which record in stereo. So this particular board gives your Raspberry Pi the ability to produce audio, high quality audio, up to 192 kilohertz, as well as record audio. So this requires a revision 2 Raspberry Pi with the P5 pads, which I mentioned earlier, because those pads actually provide the audio GPIO signals. But there are many ways to achieve this sort of I/O. You can always look towards USB products which you already know and use, and they may actually be compatible with the Raspberry Pi, so do feel free to experiment. So if you're looking for something more visual, there are options for you as well. In this case, I have a pair of Raspberry Pi cameras. In this case, we have the regular Raspberry Pi camera and also the No IR edition. And these two cameras are based on the same sensor. They're based on the OmniVision 5647 backside illuminated sensor, which is 5 megapixels. And the camera itself is a fixed focus camera which comes on its own little PCB like so, and is fitted with a flat flexible cable which you use to attach it to your Raspberry Pi. So you'll use the flat flexible connector just right near the Ethernet port, which is the camera serial interface, to attach this. So this one's the regular one. The No IR one differs from the regular one because it does not have the IR cut filter on board. So by not having the IR cut filter, the camera can be sensitive to infrared light, and that's useful for, say, projects where you need night vision and you use infrared illumination. The cameras themselves are also capable of video, 1080 progressive at 30 frames per second, 720 progressive at 60 frames per second, or 640 by 480 at 60 or 90 frames a second. So the other thing which you'll probably appreciate is that there is software available which allows you to exercise control over almost every aspect of the camera's operation, things like white balance, things like exposure. So you can adapt it for your own use with your own software. So while the Model B Raspberry Pi has Ethernet on board, I'm sure many people at home will be running wireless networks. And they would appreciate the ability to use their Raspberry Pi when it's not connected by cable. So one way around this is to use a USB wireless adapter. There are many USB wireless adapters available, but only the ones using chipsets which are supported by Raspbian will work. So one of the products which is certified to work is Element 14's Wi-Pi. This is a single band, single stream wireless N adapter. It works at 2.4 gigahertz and has a physical interface rate of up to 150 megabits per second, and is certified to be compatible with the Raspberry Pi. So it's as simple as plugging this into the USB port of your Raspberry Pi and going through the Wi-Fi config utility to get onto your network. So this is by no means an exhaustive rundown of all of the available accessories. For example, there is the NXP Explore NFC board, among others, but the range of accessories continues to increase over time as more people start building accessories for the Raspberry Pi, and this increases the realm of possibilities available to you as a Raspberry Pi user. But I hope this has given you a taste of some of the more common peripherals available for the Raspberry Pi, and illustrates to you just how extensible it is and how you can have your own code interacting with the real world. It's really the point where software and hardware come together. So let's take a look at how you get started with your first project. I suppose the most important thing is to get some sort of idea or inspiration. What do you want to achieve? So this could be a variety of things. You could want to learn how to program in Python or C. Maybe you want to learn more about using Linux, or something like running an XBMC media center or a file server. or to internet control something as simple as a desk lamp, or you want to make an internet controlled pet feeder, for example. Or maybe you're interested in software-defined radio and you want to have some sort of receiver, say an aircraft plotting device, wireless weather station decoder, or you want to build a firewall router, Tor proxy, TV tuner server, or try some video signage or presentation. These are all things which are possible with the Raspberry Pi, and it really comes down to what your imagination is and what your level of experience in coding is. So places to look for inspiration include things like blogs scattered around the internet. If you do some searches about what you think you might want to do, you may find someone else with a blog who shows you just how to do some of it. So there may be even tutorials available online. And if you look at the Raspberry Pi Foundation's website, there's always a list of new and exciting projects which people have undertaken with the help of the Raspberry Pi. And finally, there's always the Element 14 community, where there is the Raspberry Pi projects area, where you can get some inspiration about what you might want to achieve with the Raspberry Pi. So if you've been paying attention along the way, getting started with the Raspberry Pi shouldn't be very difficult, because you would have been able to avoid many of the common pitfalls along the way. So the first thing you need to do is to have an SD card with an appropriate image of your preferred distribution for the Raspberry Pi. So if you have already obtained a preloaded SD card, you won't need to do this. You merely just have to use the SD card. But if you're starting off with a blank SD card, then you will have to go to either the Raspberry Pi Foundation's website and download an image from there, or maybe to another website where they are offering a distribution for the Raspberry Pi, and download it from there. And what you have to do is unzip the image and write the image to your SD card. This isn't as simple as just dragging and dropping or copying the file from your computer to your SD card. You actually have to write the image to the card raw. So in order to do that, under Windows, you can use a tool such as W32 Disk Imager, or under Linux or Mac, you can use a tool such as DD, but do make sure you check your destination carefully. If you don't, you may end up wiping out something which you care about. That could include your hard disk or another USB thumb drive or an external drive. So just make sure to double check that destination. The next step you'll need to do is to assemble your system. So if you have a Raspberry Pi, the first thing you probably want to do is to put it in its case. So here I've got a white multicom case, and it's as simple as working out which way the board goes around, slotting it into its clips, and pressing down. And so now it's actually housed into the case, and then you can clip the top on. So that's one Raspberry Pi in its case. So the next thing you will need to do is to plug in all the required accessories. So first step is to plug in the SD card. So just make sure the SD card goes in firmly all the way into the socket. You'll need to connect your display, so your HDMI cable should go into the HDMI port, and the other end should be connected to your display, where the input has been selected to come from this particular HDMI port. Likewise, on the USB connectors, you'll probably want to plug in your USB keyboard and mice, and then plug your power adapter into the wall, and then finally plug the micro USB power connector into the Raspberry Pi, and it should start booting up. Because the Raspberry Pi doesn't have a power switch, you should always apply power last. Don't apply power and then plug in SD cards, because that might cause damage to your Raspberry Pi. Also, if you want to use Ethernet, you should also connect Ethernet, say for a Model B. So hopefully on your screen you should see some scrolling text which indicates that the Raspberry Pi is booting up. But if not, there could be many reasons why it's not working. So the first thing to do is check your SD card, make sure you've got the right image and properly imaged to the card. Make sure it's plugged in firmly all the way. The next thing to check is check power. Check that you've plugged in the power. Check that the power is to the right specification. Make sure you've plugged in your display correctly. Make sure the display input is set correctly. And maybe even try editing the boot.txt, the config.txt inside the boot partition to force, say, HDMI safe modes in case your display is not compatible. but you should also take a look at the SD card activity indicator light. So you should see some blinking going on when it's booting up. If it's not, then there could be a problem with SD card compatibility, or maybe it's not firmly seated in its socket. There are a multitude of things, but generally it's quite simple to get a Raspberry Pi going, and that shouldn't really daunt you, because it should just be a case of plugging it in and off you go. What you will see on the screen is a set of prompts which you can follow to set things like the password, expand the partition size, set the locale and time zone, enable or disable SSH and graphical user interface. So if you do have problems, help and information is always available. The Raspberry Pi Foundation's website has a lot of frequently asked questions, as well as a forum where there is a lot of information and discussion. elinux.org is a wiki-style encyclopedia to exactly how to troubleshoot these issues and what sort of common problems there are, as well as listing things like compatible hardware peripherals, and there's always the Element 14 community areas. So let's take a look at what the differences and limitations of the Raspberry Pi are. So the Raspberry Pi is different to most microcontroller-based platforms because it runs a fully fledged Linux operating system. So instead of being very basic and limited, you have access to a wide range of high-level programming languages and software packages which you can use to create your software. It's extremely valuable as it lets you develop more easily between, say, a desktop or a laptop computer and port that over to a Raspberry Pi, or vice versa when you feel that a Raspberry Pi is not enough. So you can go both ways, and there's not that much need to refactor your code. However, you have to keep in mind that the Raspberry Pi is not as powerful as computers of today, so you shouldn't really be using it as a desktop replacement, and if you are, you can't expect it to work as smoothly or as quickly as a desktop would. Another thing you need to think about is the nature of multitasking. So the Raspberry Pi itself features a single-core CPU, and it has to run all of the threads, say the operating systems and background processes, in addition to your program. So as a result, if you're doing things with, say, the PiFace Digital, where the timing is critical, the CPU may actually be busy doing something else when, say, an input is happening. So unfortunately, the ability to do precise I/O time-wise is relatively limited because of this. But there are ways around it, say, for the Girduana, where there is actually a secondary microcontroller that is doing all the I/O and merely communicating with the Raspberry Pi CPU. So you'll need to think about that if your project requires precisely timed I/O. The other thing to think about is that the Raspberry Pi's power requirements. So it does require more power compared to a majority of microcontrollers, and that's expected because it is faster and it does do more. However, if you're looking to run projects off battery, this could be a bit of a problem, as the current requirements mean that you need a stable power supply that can supply a decent amount of current, and it may mean that your project will not run off battery for as long as you might expect. The other thing is that the Raspberry Pi absolutely requires 5 volts to operate. You should not supply it any other voltage, otherwise you risk damaging the Raspberry Pi. So this will necessitate things like DC to DC converters in most battery-operated scenarios. I'll also remind you about the power limitations on the on the USB ports. So they're not really suitable for high current devices because the power is coming through the Raspberry Pi's micro USB connector and through its polyfuse as well, and you shouldn't be hot plugging devices, otherwise you may cause the Raspberry Pi to reboot unsafely, and that could cause damage to the operating system. So there are some aspects to the Raspberry Pi which is similar to a computer. Say a computer needs to be safely shut down. It's the same thing with the Raspberry Pi. Now, I did mention a little bit earlier, while the Raspberry Pi does have GPIO, the number of pins are relatively limited and they are relatively fragile. They cannot source or sink any significant amounts of current, so please be very careful with them if you're working with them directly. I would recommend that you use expansion boards such as the Girduana or the PiFace Digital just to provide that level of protection to the pins. Otherwise, you could end up needing to replace the whole Raspberry Pi. So if you think about it, the Raspberry Pi isn't simply just a more powerful Arduino. It has its own character. There are limitations as well, which you'll have to think about and decide whether it's right for you. In some cases, you can make a very powerful combination by combining a Raspberry Pi with an Arduino. So there you go. So the other thing is the ability to run high-level programming languages makes it easy to port software. I think that is a major benefit, especially if you would like to make more complicated projects, such as ones which access the network or which require networking, or say is Linux script-based. You can easily port them from a Linux desktop to the Raspberry Pi, which opens up your code to running in such a small, portable form factor. It also serves to highlight all the benefits and positives of open source software collaboration, say where you can actually inspect, use, modify, download, and tailor code to your own needs. And it is an ultimate motivator when it comes to learning how to program, because you can actually see the fruits of your own labor. You can see how your effort goes towards making something that you will enjoy in the future. So in conclusion, there has never been a better time to get into microcontrollers and embedded systems. There's a wide variety of low-cost, highly capable platforms available, and the Raspberry Pi is definitely one of them. The Raspberry Pi has strong community support, which is very valuable when you need help, and it has also seen wide adoption. And this means that there are a wide range of peripherals which are available, as well as a wide range of software and software distributions available for you to use, and even project ideas. So purchasing the Raspberry Pi itself is not sufficient to get started with the Raspberry Pi. You need to budget in the cost of purchasing some essential accessories that go towards supporting the Raspberry Pi itself. And depending on what your project aim is, you may even need to buy additional add-on boards to realize the full potential of the Raspberry Pi. By following the tips that I've given today, you can avoid some of the more common pitfalls which Raspberry Pi users may experience, and that will make your Raspberry Pi journey as painless as possible. It is as simple as writing an image to an SD card, plugging in everything you need, applying power, and off you go. In the future, further add-on accessories will be available from vendors, both third-party as well as Element 14, and that would mean that the possibilities open to your Raspberry Pi will continue to increase. So keep a lookout for these new accessories. They might just be what you need for your next project. And remember, the Raspberry Pi was not designed to be a computer replacement, so be patient with it and respect its limitations, and in return it will surprise you just how much you can do with so little. I hope you've enjoyed this webinar. As we have some time, I'll take some questions before we close off.
Thank you, Gough. We have our first question from Martha Aragon. She just wanted to ask about the Media Center OS. She's recently purchased a Raspberry Pi and was wondering if you could provide her with a recommendation of what Media Center OS she should go with. She's tossing up between OpenELEC and Raspbian, but she also saw the Raspbi OS, which apparently has amazing audio settings for audio files. And she wants to know if by running this specific OS, will it still let her view videos or listen to music in the same manner as you would with OpenELEC or Raspbian?
That is an interesting question. It highly depends on what the aim is, I suppose, because depending on the type of video files you want to view or the format of the audio files you want to view and the hardware support you need, different distributions have their own advantages and disadvantages. So say Raspbian is quite a common media center distribution to use, as well as OpenELEC. They're both based around XBMC. They are quite general purpose, and they will play a wide variety of media files which most people will encounter, but their hardware support may be a little bit different, whereas Raspberry Pi OS is more centered around those who like to enjoy their audio and use USB external digital to analog converters. So those people who enjoy their hi-fi, like to use, say, USB DACs, they would probably be more interested in Raspberry Pi, but some of the things are really coming down to optimization and tweaking, whereas Raspbian is a general purpose operating system where you can basically run almost everything that you can think of. You can think of it as a general purpose Linux distribution. So in terms of Raspbian, if you were running that as a media center, it would mean that you would either need to do some coding, or maybe you would need to download some different front ends for it, or a media center application for it, because Raspbian is just a general distribution which you use just to run your everyday Linux programs. So it really comes down to what your needs are, and I would encourage everyone to experiment and explore, because it's as simple as imaging or re-imaging an SD card, so you can easily back up your current distribution and then put something new on it just to have a play around. And also keep in mind that with open source software, bugs and functionality continue to evolve at a rapid pace, so limitations which we might see today might be gone tomorrow. So just keep an eye out, I suppose, for the changes that happen from day to day sometimes, and do try it out for yourself and see what works best for you.
Okay, we have a next question comes from Leo Thomas. Like to know, there are a lot of operating systems available, and Leo's a newbie. What's a good OS that you would recommend for an absolute beginner, and also for video TV streaming, though you may have addressed this in the previous question?
Sure, not a problem. I would say that for most people just beginning with the Raspberry Pi, Raspbian is the operating system I would most recommend. The reason for that is it's a very general purpose operating system which is quite similar to many Linux distributions around. Say, if you're familiar with using Ubuntu, you will be quite at home in Raspbian. Likewise, Raspbian also has a wide range of software packages available for it, so regardless of the project you're seeking to embark on, you'll have the widest possibilities under Raspbian. Now, some of the Raspbian comes with some bundled applications, so for the absolute beginners, if they're interested in, say, programming visually, there's Scratch, there's also idle for those who want to work with Python. So there are some integrated development environments already available for people to get started with, but in general I would say Raspbian is probably the better distribution when it comes to tinkering. But when it comes to, say, streaming video, I'd say you would probably look at one of the XBMC-based distributions like OpenELEC or a Raspbian CNC, whether that suits your needs. But as with all open source, things continue to evolve, and depending on your needs, you might even find that coding up something on your own or trying something different under Raspbian is a better solution for you.
Okay, thank you for that. Leo is also asking about for a website for absolute beginners as well. You mentioned a few, but do you have a particular suggestion?
I suppose it always depends on what you want to do, but if you know of Lady Ada's website, so Lady Ada, I think she is one of the she's one of the people behind a lot of electronic stuff, and she writes a lot of tutorials. And some of these tutorials are centered around Raspberry Pi and things like, say, building your own Tor proxy or building your own this or that. And so some of the sites, like Lady Ada's sites, have very good step-by-step tutorials which might be more suited to the beginners. But I suppose we'll have to do some ferreting around, because I'm not sure whether those projects are right for you. So maybe you need to think about what sort of projects you'd like to do, and see whether you can find any tutorials that center around those projects and attack it from there.
I'd also hasten to add that we have videos targeted for beginners on element14.com. Next question from Martha Aragon. Is there a trustworthy place to source repository stroke add-ons? I've heard of XBMC Hub before, but I'm not sure if these guys are endorsed by the official Raspberry Pi stroke XBMC community.
Well, unfortunately, I wouldn't know whether they are trustworthy or not, and I suppose in almost all of open source, the whole thing always comes down to the fact that if it is truly open source, you should be able to analyze the source code, and if you are that expert, then you can tell for yourself whether, say, a certain plugin or add-on is safe for you. Now, I suppose in many cases users will be more interested in functionality over actually doing the hard work of analyzing code. So I suppose you will have to look at the consensus online and find out that way. But I wouldn't know, not off the top of my head, unfortunately.
Okay, thank you for that. Do we have any further questions from the audience? I've got one question for you, Gough, is that I became aware not too long ago that the German Passport Agency is using Raspberry Pi for its rapid prototyping activities. What kinds of developments do you see from Raspberry Pi moving on hobbyist to much more serious applications?
The Raspberry Pi, as a rapid prototyping platform, it's great because there is just that much software support in terms of, say, Linux software packages available, libraries, say if you're coding in C or you're coding in Python. That just makes it very quick to, say, write something up. So it wouldn't surprise me to see more of this being employed in areas such as like access control and, say, NFC. So with the NFC Explore, for example, then you can do things like program and read contactless badges, key cards, and that sort of thing. I've already seen people using it to run things like video walls where there may be 3x3 monitors and they're all arrayed together to play a video to make one large video display, and that's based around having one Raspberry Pi drive each of the monitors themselves. I think it really comes down to just the ubiquity of the Raspberry Pi platform. It's easy to get one. It's easy to code for it. It's easy to back up the images, create new images, and adapt it to your needs at any given time. So I think as more and more hobbyists start hopping onto this maker revolution and becoming more proficient with, say, development platforms, that you'll see a lot of these so-called rapid development or rapid prototyping hardware start moving into serious professional applications.
Okay, thank you for that. Let's see if we have any further questions. Yes, Drew Ward is asking, Gough mentioned using a PiFace controller and display to show details about a song playing. Do you have an example for that software?
I don't have an example as such, but I'm pretty sure that one of the example libraries does show you how to export, say, live information from a running process to the display on the PiFace control and display, and it's based on Python. There is also a demonstration which shows, say, different say, resource utilization statistics. So, say, how much RAM is being used, what the load averages are, what the temperature is, being written to the display. I do know of a example on the PiFace control and displays website which shows you internet radio type situation where you can have IR control as well as showing the current playing station on the screen, and it wouldn't be far from that. So I encourage you to check out that particular example because it's pretty close to what you're thinking of at the moment.
Okay, thank you for that. I think if there are no further questions, we can close the session. I'd like to thank you, Gough, for this interesting and engaging presentation, and which I'm sure will inspire many to take up using Raspberry Pi. And with that, I'd like to thank you once again for this great webinar and say goodbye. Goodbye, everyone.
Thank you for the opportunity, and goodbye.